Petchy's Corner, we're going to look at graphing quadratic functions. So before we start graphing, what is a quadratic function? Well, that is one described by the equation, and we have this kind of set up form. F of x is equal to ax squared plus bx plus c, where a cannot equal 0. And what that means is x squared is the highest power. We're not going to have x to the first power. We're not going to have x to the third power. We are going to have x to the second power. Now, what does that look like? We call this graph of the quadratic function a parabola. It looks kind of like a U. It'll either open up or it'll open down, something like that, like a U. Now, it's very important to understand all the different aspects of a quadratic function. So I like to break this down with kind of a little phrase to help you, UDAVI, MMDR. So this is the important information that you're going to pull out from the quadratic function that you're given. It's best to identify this before you graph the parabola. So when we start with this, UD stands for the parabola, whether it opens up or if it opens down. Well, how do we know? The A value. If the A value, that coefficient before x squared, is positive, the parabola is going to open up. If it's negative, it's going to open down. Now, the axis of symmetry, that's the line that's going to go right in the center, has the equation of x is equal to negative b over 2a. And now that's a line, not a point. That's different from the vertex. The vertex is a point. We're going to find the x coordinate, which again is going to be right on the axis of symmetry. So we're going to use x is equal to negative b over 2a, which will be the center point of the graph. And how do we find the y coordinate? Well, we're going to substitute this x into the original function. Now, when you're doing this, to kind of make your table look balanced, we are going to make the vertex the center point in the table. Now, in the UDAVI, the y stands for the y-intercept, where it touches the y-axis, and that's actually going to be our constant, the c value. Now, our second part of that, MMDR, the MM, max or min, it has one or the other. If the a value is positive, it'll have a minimum value. If a value is negative, it's going to have a maximum value. It will have one or the other or not, but not both. Then from there, the last thing we're going to do is we're going to identify what the domain and the range of our parabola is. All right, let's get started. Here's the first one. It says graph a quadratic function using a table. And it says we're also going to identify that UDAVI, MMDR, and then we're going to graph it. Okay, so the first thing we're going to notice, and I have it kind of set up here. My A value is a 3. First of all, this isn't standard form, so I'm okay. The A value, which is 3, which is positive, so that means that we are going to open up. Our parabola is going to open up. Now, the axis of symmetry we need to find. So our A value is equal to 3, our B value is equal to negative 12, and our C value is equal to 6. So when we use our equation, negative B would be positive 12 over 2A, which is equal to 6, so that would give us 2. Okay, so our axis of symmetry is going to be x is equal to 2. Now, our vertex we talked about also is going to be x is equal to 2. It's that negative b over 2a. Now, how do I find that y value? Well, we know f of x is equal to 3 times 2 squared minus 12 times 2 plus 6. So when we do all of that, our x value is going to equal negative 6. That's our vertex there. Okay, so our vertex is going to have the point 2, negative 6. So we're going to put that actually in the middle of our table. So let's go back and just kind of do that now so we don't forget. We have 2 here, negative 6. Now, what will our y-intercept be? Well, our y-intercept is going to be our c value, which we set up here is 6. So it's going to be 0, 6. That's where it should touch our y-axis. Now, maximum or minimum. And we'll look at that when we graph it, so it makes a little bit more sense since this is the first time we do it. And we'll do the same thing with the domain and range. Once we do one together, we'll take a look at it. All right, so let's go to our table. We know, again, that our vertex is right here. We put that right in the center. So you can use any values you want. I obviously like to use values that are easy to work with. I'll use 0 and 1 and then 3 and 4. And you will substitute each of these into our original function and get the x value. So this gives me 6 -3, -3, and 6. So let's graph it. So I have 0, 6 is going to be here. Then I have 1, -3 is here. 2, -6 is down here. 3, -3, and then 4, 6. So when we graph this, we kind of do the best we can. It's going to look like a U, and we have arrows on the end. Okay, so let's finish that UDAVI MMDR information, and we can kind of check what we have. Also, this 2, -6, 2, -6, you see that's our vertex. That's where it changes the shape. It starts to go down, and then it goes up. Our y-intercept is at 0, 6, which is up here. We have that correct. Now, our maximum or minimum value. Then we know with these arrows on the end that this parabola or this function is going to be continuous. So if you remember, we talked about the fact that you're going to have a maximum or a minimum, not both. So right here, this is the minimum value we have. We're not going to go any lower. So our minimum value in this case is going to be -6, or that point to -6. Let's fix that a little bit. Okay, our domain. So what can our x values be? Well, we can go from left to right as that parabola goes up. So our domain here is going to be all real numbers. Now, what about our range? That's our y value. Now, we know as it goes up, we're going to continuous. That's okay. But again, we talked about the fact that we have a minimum value there at -6. So we're going to say our range is f of x, the function of x, such that, that's what that means, f of x is going to be greater than or equal to -6. Let's go back for just a minute and take a look again at that axis of symmetry and what that is. So remember, the axis of symmetry is a line. So what it is actually is this line that goes right in the middle. Sounds exactly like it is, the axis of symmetry. So we're going right down the center, and it's going to be symmetrical, right? X is equal to 2. That's what we found over here. And we're going to say that what happens with that axis of symmetry, it's like looking in a mirror. It's going to be symmetrical from one side to the other. Now, we did ours by hand, so it doesn't look exactly symmetrical because the graph's off a little bit with the curving of it, but overall, you get the idea. Okay, let's look at our next one. We have the function here. So we know our a value is equal to -1, our b value is equal to -4, and our c value is equal to 2. Okay, so let's take a look at our UDAVI information, MMDR. We know that their a value is negative, so we know this is going to open down. Our axis of symmetry is going to be x is equal to negative base. It's going to be +4 over 2 times -1, which gives us -2. Okay. Now, our vertex, again, is going to be -2. That's our x value. And then when we substitute it into our equation, let's see what we get. We get minus -2 squared minus 4 times -2 plus 2. So this gives us -4 plus 8 plus 2. So that's going to give us +6. Now, again, we'll put that in the center of our table. Now, our y-intercept is our c value. So our y-intercept should be 2. Now, we'll come back again to our max or min. I like to look at that after we have the graph, just so you kind of understand why that works. And we'll do the same thing with the domain and range. Okay, so now again, I have -2. So I like to use numbers that are easy to work with, that aren't too far apart. So there will be my values. Now you can take a minute, you can pause the video if you want, substitute it in so you can find the f of x or the y. It gives me 2 and 5, 6, 5, and 2. Okay, so I'll plot these points. -4, 2 is here. -3, 5. -2, 6 is here. -1, 5. And then 0, 2. Okay, so now connected. And again, looks more like a U, not a V. It's not an absolute value. And we'll go from there. So let's take a look. Our maximum, minimum. Now we have this point at the top. Whenever it opens down, we're going to have a maximum. Okay, so we have a maximum of 6. So that's negative 2, 6, so our maximum will be 6. Our domain, again, our x values. We can go from left to right again, so that'll be all real numbers. Now, what about our range? Well, we talked about our maximum is 6. We can go any numbers below 6. So we have f of x such that f of x is less than or equal to 6. Now, again, let's go back and take a look at what we've had in the beginning, things we labeled. So we said it opens down, which it does. Our axis of symmetry, remember, that's the line that goes right down the center. And we said that that line will have an equation of x is equal to negative 2. X is equal to negative 2. So let's take a look again. Negative 2, it goes right down the center through our vertex. We said that, again, our vertex is negative 2, 6, which is what we have. Our y-intercept is 0, 2, which is what we have right here. So it looks like we're all set. We have double-checked everything else. Great job today. Have a good one.